So the final exam, when is it? It's
the 16th.
Here I'm at 21. Yeah, right, it's Tuesday, huh? Final exam is Tuesday from 1 to 3. Yeah, we're here for 2 hours. 1 to 3? Oh yeah, we come early. Yeah, half an hour early. Take note of that on the finals schedule. Yeah, we come a half an hour early, not at 1:30. 1 to 3. Yeah, all your classes that start halfway through the hour, finals are on the hour. So 1 to 3 next Tuesday, and that's all we have. We have no class Thursday. We just, finals week, you just come to your final, take the final, and you're done. So next week, final exams Tuesday, 1 to 3.
How long do you think the final should take us if we know our stuff?
Everybody, that's impossible.
Yeah,
Because everybody's different. Yeah.
I have another final that ends at 12:50, so I have to jet over here from.
Yeah. It's going to be 26 questions. Final exam. I get some more particular information. 26 questions. What do we normally have? Like, what was the last exam? 20? It was 18. Yeah, so it's a few more. Yeah, that's right. So it's a lot. So it's like an exam and a half. So it'll probably. It'll take time and a half as long as what it normally takes you. How about that?
You can use it all the way up to.
Yeah, you have the whole 2 hours. I imagine a lot of people will use the whole 2 hours. Yeah, we have 2 hours, not just an hour and 15 minutes. We have the whole 2 hours, hour and 50 minutes. From 1 to 2:50, technically. Yeah, we have the total 2 hours, but it might take that because it is 26 questions. It covers like all the old stuff, like probably 23 questions. Is that true? Maybe 22, something like that, from exams 1 to 3. And like 4 questions from the new stuff. What did we cover after? 9192, 9192, and 11.3. It's about, I'm estimating, it's something like that. Probably about 22. So it's mainly old stuff. It's not mainly the new stuff, it's mainly the old. So mainly what you want to do is go back over those old exams. I'm going to put the keys up. We'll start even today going through those old exams. And I'm going to put the answer keys for exams. Answer keys for exams 1, 2, and 3 on mathexcel.com underneath, it's called announcements, like, where you find the practice exams. Under announcements by Friday. So by Friday, I'll put up all the answer keys so you can, use those as study guides. You know all that? Answer keys? Answer keys under, for example, 1, 2, and 3 under announcements on MathExcel by Friday. So that's the best thing to study. Just go over those old exams. I promise there's nothing on that final that hasn't been on an exam. Yeah, so I'll put A and B.
Okay.
Put A and B. Yeah, so you'll have double.
Okay.
A and B, because there was a blue and a yellow, right? So I'll put the blue and the yellow keys for 1, 2, and 3. 6 keys technically up there online. You can study off those. And there'll be nothing on the final that wasn't on one of those exams other than those 4 questions from the new stuff.
So the questions will be set up similarly.
Oh, really? So the formatting will look the same, exactly the
We
same.
had to set up the simplex.
Yeah, so there'll be one of those, like set up the simplex, there'll be one of those, solve the simplex. Yeah, exactly. It'll be all the same kind of stuff. Yeah. So you want to review, though. It's been a long semester. 18 weeks. Really, it's just so, seasons have changed during this class, right? I went to Cal Poly, we had 10-week quarters. In, out, done. This 18-week thing is long. So you really need to review for an 18-week course final, because it's been a long time. So go back, and we'll start even today. All right, anything else? Oh, and my office hours, I already put those up. My office hours, they're for this week are normal. This is the last normal week. This week, this is what, Tuesday? So I've done Monday, Tuesday already. So I have Wednesday and Thursday left, 9 to 9:50. Next week, they're different. What are they? They are Monday, 9 to 11. That's really all you care about because, Tuesday. Tuesday, 10 to 11. So I have those both before your guys' Tuesday final. Ours is Tuesday 1 to 3. And then I have other ones that you don't really care about because they're after your final. Wednesday 9 to 10 and Thursday 9 to 10 as well. So anyway, and I'm down the hall. You guys know where I'm at. Down the hall, MSE 5. down the hall. So come and see me. Tutoring's available. Go over those old exams with the keys. We'll do some of that even today and Thursday is the plan. Questions on the final? So it's worth 100 points, right? Each of the exams is worth 100. Isn't that what the syllabus says? Let me just double check. I think they're all worth 100. It's just even, Steven. Yeah. Each of the exams is 100. Finals 100. Homework's 50. Everything's online right now. All the points. You know how to get your grade, your current grade, right?
You're gonna do partial points for the questions on the final exam too?
Yeah. Just same change. So how do we find the average? What do they mean? I know we barely did this last time. Average rate of change. Anybody remember?
Function of b minus function of a over.
Yeah, slope, right. F of b minus f, exactly. It's slope. It's fancy talk for slope. So whenever you see average rate of change, just think slope. They're talking about slope. Okay, so how do I do slope? Remember the slope formula, y2 minus y1 over x2 minus x1 from your algebra days? Remember that m equals slope formula thing? But what are the y values? The y values, remember, are the f values. This is f2 minus f1. What do I mean f? Meaning f of x at 0 and 8. So in other words, this is going to be f of 8 minus f of 0 over 8 minus 0. Everybody see what I did there? Because this is x1, x2, right? 0 and 8. So here they are. x2 comes first, then x1. And on the top, f of x2 and f of x1. Because remember, f values are y values. Good so far? So on the top, you put the difference of f values, because those are y values. The bottom, you put the difference of x values. Now, what is, here's my function f of x squared plus 10x. What is f of 8? Just plug in that 8, huh? Yeah, 8 to the second plus 10 times 8. And that's some big number, 80 and 64, 144?
Yep.
And then f of 0 is 0 squared plus 10 times 0. That's an easy one. 0 squared is 0, and 10 times 0 is 0, and they add up to be 0. So there's f of 8 and f of 0. So I'll bring that over here and over here. So it'll become 144 minus 0 over 8 minus 0. And that's 144 over 8. Does that do something nice? 18, thank you. And that's our answer. 18. Does that make sense how I did slope there? Slope is difference of y's over difference of x's, right? y2 minus y1 or x2 minus x1, and y values are f values. Why do we call that average rate of change? I want to give you something that makes sense. If you have a little bit of room over here. So it's slope, or why do I call it slope? Because you think about it, if you have a function and he goes from here to here, say, that's kind of like what we're doing. That's clearly the slope. It's also average rate of change, meaning we're saying this height y1, this height y2, from this x1 position to this x2 position. We mean during the x1 to x2 trip, what is the average rate of change of the height? Something like if you're mountain climbing, for example. How fast is the elevation rising, right? So if you're driving uphill, right? Well, so I just changed to driving from mountain climbing. So if you're driving uphill, right, and how fast is your elevation rising? You know, when you get in really steep places and you see the sign 5,000 and 10 minutes later 6,000 feet, you're going up fast, right? So that's kind of like what we're doing. So steepness, another way to think about that, slope, steepness, is average rate of change. It's how fast your height is changing. That's what steepness is, right? The steeper something is, the faster your height changes when you go along the ladder. Right? If you set the ladder almost straight up and down, your height changes quick as you move. If you set it almost flat, your height doesn't change much as you move along the ladder, right? So average rate of change, how fast the function changes, which is the y value, function values are y values, is slope. All right. All right, try that one. Average rate of change. So we're difference of f values. So what are my two x values? -4 and 1. So watch your signs carefully. This is x1, this is x2. Huh? So you know average rate of change, how fast the height is changing, is called slope, right? How fast is the height changing? That's called slope. What is the average rate of change? Slope. F of x2 minus f of x1 over x2 minus x1. F values on top, x values on the bottom. Because f values are y values. So x2 x2 is 1 minus, so it's going to be 1 minus minus 4. It's going to be 1 plus 4 on the bottom. Huh? It's going to be 5.
The bottom, that's y, right? Or those x's?
So f values are y values.
Okay.
Yeah, so that's exactly what I'm saying. This could be called y2, or it could be called f of x2. Same thing. Yeah, so f values are y values. So, okay, so what's f of x2? Well, f of x2 is f of 1. So what's that? Plug in 1 to the function. Minus 1/3? Good so far. Minus, and then f of negative 4. What's that? 1 over negative 4 minus 4, 1 over negative 8. You careful with all those minus signs? That makes sense there, what I've written? So this is f1, f of 1, and this is f of negative 4, and they're subtracted. This is 1, and this is negative 4, and they're subtracted. So let me pause there for a second. So everybody see how you calculate the slope? So on the bottom, you take the second x value minus the first, and then f of the second x value minus f of the first. Good so far? Okay, now, double negative. What did negatives head to head? Positive, right? So these guys will become positive. And so we'll get negative 1/3. Didn't write. Kim. So negative 1/3 plus 1/8 over what's that? 5 on the bottom. Now you can use your calculator. It's fine with me. Just get a decimal. I don't care. Just go ahead and whip it out. Oh, they want a fraction answer. Yeah. All right. I don't care on the test. Decimals are fine with me. They say fraction here. They want a fraction. So that's a little painful. Going to have to add those. How do you add two fractions on the top? Common denominator, remember? So you multiply this one by 8, top and bottom, and this one by 3, top and bottom. So you get minus 8/24 plus 3/24 all over 5, which is minus 5/24 over 5. Good so far? So I just combined these two on the top. Minus 8 plus 3 made minus 5. Now what do you do with a fraction over a fraction like that? It's kind of weird looking. What do you do with that thing? You take this 5 over 1, make it look like a fraction, and you flip it up. Have you ever seen that before? So you grab that denominator and you flip it upside down, becomes 1/5, and you become multiplied. Like that. That's because you're dividing by the bottom. Remember? Because really what it means is it means minus 5/24 divided by 5 over 1, right? Because minus 5/24 over 5 over 1 means divided by, doesn't it? And remember dividing? You change to times and invert the one in the right. See how it does that? So I'm just skipping all that in one quick step and just grabbing the bottom and flipping it up. That's the same result as flipping the one on the right, because the one on the right is the one on the bottom, isn't it? That makes sense? You're dividing by the bottom like you divide by the right. So that's why. So what ends up happening is the 5's cancel. The 5's cancel. And you get minus 1/24. There's our answer. Good. On the test, I'm fine with the decimal. You just type it all in your calculator and hit the button. That's fine with me. Questions on that one? So that's the slope, which is the average rate of change of the height. It's how fast the height is changing. We all good? Can I move on? Everybody got that one down? Feel comfortable? All right, so there it is, same thing. So you know the deal, right? They're giving me the two x values. So slope is going to be f of 4.5 minus f of 4 over 4.5 minus 4. Getting the hang of that? It's just always f of those guys subtracted on the top minus those guys themselves on the bottom subtracted. You always put the second one first. So just use your calculator. You're going to get some ugly decimals. They want us, oh yeah, let me give you a little hint on that. They want us to round to 3 decimal places. What that means, whenever they want you to go to a certain amount, that means before you get to the end, in the middle of the problem, you better use a couple more places of accuracy. So let's use like 5 places maybe, decimals, throughout the problem, and then at the end we can round back to 3. If you start using 3 right from the beginning, your answer is not going to be right in the end to 3 places. So you need a little more than they're asking for in the end along the way. So let's use 5 places. So I would just say, all right, I'll do the bottom. The bottom's 0.5. That was easy. But the top's the hard part, right? So on the top, or I'll bring it over here so we have room. The bottom's just 0.5. But the top, we're going to need to say, okay, what's f of 4.5? Plug 4.5 into that function, 0.4083 e to the power 1.391 square root of, and what was x? 4.5. So everybody see what I did there? I plugged 4.5 into the x slot. That's where you plug into functions, right? The x in a function is like the holes in a toaster. It's insert here, right? It's where you plug in things. So that's just hit the buttons on the calculator. So get that one, and then get the f of 4, same thing, 0.4083 e to the 1.391 square root of 4. I'm going to go grab my calculator and get you the right decimals up there.
How would you do the e squared?
Use the e button on your calculator. You have an e to the x button.
Oh, okay.
Did you guys find that e to the x button okay?
Yeah.
So the way I would do it to make well, you can just type the whole thing in. There's a lot of different ways, but 4083. There it is. There's the e button. I had trouble finding it. 1.391 times square root of 4.5. So I'm getting, for the first one, I'm getting 7.80686 6, 5, 3, 3, 1. You don't need all those decimal places. You guys getting that? For that first, for f of 4.5 and f of 4.4083. It's right above the natural log key. See the e to the x? It's above the natural log key. The ln, it's above the ln key. Got to hit second in the ln key for most calculators. And the other one, I'm getting 6.5945722217. Y'all getting those?
For the first one, mine ended at 7.80687. I didn't have all the extra. At the 6, it rounded the 6 up to a 7.
Because you're set in a mode of like 3, 4, 5 decimal place. You lost the pink calculator, huh?
Oh, I have it.
Okay.
I just don't know how to do that on the pink one.
Oh, really?
I switch back and forth.
Oh, okay. Yeah. So that one's rounding to 5 places. There's some kind of setting right now, which is fine.
Does that matter?
Then it'll be fine. Yeah.
Are you typing this in? I mean, you're not doing this in.
Oh no, I'm just doing.
The 0.0.
Yeah. Want me to show it on the screen here? Let me flash it up on the overhead.
I got it.
See if you all
Thank you.
good there. Yeah.
Oh, he's okay.
Light thing. It makes it worse sometimes. Let's see.
Oh, I got it now. I have it. Thank you.
Yeah. So make sure everybody's good here.
Okay.
There we go. See what I typed in there to do the two of them? 0.4083 e to the power. Did you find that e to the power button? And then 1.391 times the square root of 4.5. I didn't even do any of the closing parentheses. You don't even need them. As soon as I had the 4.5, I just hit enter. There's the first answer. Here's the second one. You can read that. Y'all able to get those
No.
with the graphing calculator?
Why is it 1.391 times 2?
Because that's what the thing said.
What's your second one?
Oh, because square root of 4 is 2. Sorry. I just was doing that without even thinking.
Oh, okay.
This right here? That's 2, right? Square root of 4?
Okay. Yeah. Makes sense.
You can put square root of 4. It'd be the same. Is that okay? So those two answers? On that?
That one was 4.5. Did I put it in wrong or something?
No, that looks right. Oh, yeah. You just switched the 8 and the O in the beginning. I didn't notice it first either.
The what?
408, not 480.
Oh.
Yeah, otherwise it's all good. You guys able to get that? All right, so any other questions, grab me after. I can help with calculator stuff, just probably 10 seconds, you know. And then, so let's finish it up. We got to subtract these two numbers. So the 7.80686, and that's enough places right there. You can make that 7 or whatever. It's it's enough accuracy. 6.59457. I won't even, good enough. Subtract those and then divide. So let me see, 7.80686 minus 6.59 over 7 equals 2.424. Oh, rounds to 5 actually. Yeah, it was 458, so they'd round to 2.424. Oh no, wait, three places. 2.425. Good. Yeah, because they want you to stop. Yeah, they say 3 decimal places. So that means you circle the third place and you look one to the right. If it's 5 or more, you round it up, right? So that 4 rounded up to 5. 2.425 is our answer. Good. All that mess. Questions I can answer? All right. Let's make sure it likes that. 2.4. Let me show you. Same thing. They're just going to keep hitting this same drum. And so now they're going to say, okay, use a graph to estimate the average rate of change. What's that? Slope, right? So every time you see that average rate of change, that's how fast something rises, right? Rate means how, whenever I talk about a rate, that means how fast it happens, right? So that means how fast it's rising, that's slope. Of blah, 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 94 to 2000, that's your x1, that's your x2. Then they're going to have us do part B, do it all again. I've already got the answers there. Let me show you how I got them when I did these earlier. x1 is 1994. Okay, so let's go to the graph. Look at this graph. Can you tell where 1994 is? You know, maybe I should make that bigger. Here, let me do that. All right, so we'll use this version. Okay, so there it is. And we're going again, 1994 to what was the other year? 2000? Okay, to 2000. They want us to find the slope, average rate of change. Okay, so you go to 1994. That's right here, huh? This is 94. See how the years, you know, this must be 95, 96, 97, 90. See how it's going down there. So 1994 is that. How high is the graph at 94? At the x1 value 1994, what's the y value that goes with that? Well, 0. It's at a height that's 0. The dot is at 1994 is up 0, huh? Okay, what about at the year 2000? This is your x2 value, 2000. What's the y value, the y2 value, that goes with the 2000? Well, I have no idea. It's not even on the screen. Oh, no, there it is. This must be 2000 right here, huh? So that's up there, right there. Can you tell how high that is? Looks like 20, huh? Follow the line. It's at a height of 20. So it's at a height of 20. Does that make sense how I'm getting this is going to be easier. We don't have to plug in anything. We're just getting the x, y off the graph. Now we just subtract those numbers and divide. We're done. Does that make sense? So it's all about, I'll finish it. But so far so good. Does it make sense? Like get an x, get a y, get an x, get a y. So they gave me the two x's. I just went to those two dots at 1994 and at 2000, went straight up to the graph and then straight over to find my height. And then the slope is always y2 minus y1 over x2 minus x1. So the slope must be 20 minus 0 over what? 2000 minus 1994. So it's 20 over 6. What do they want, a fraction? I wouldn't care on the test, fraction, decimal, whatever. I think they want a fraction. So I'll divide by what, 2?
Decimal.
Oh, they want decimal?
3.3.
Oh, okay. Oh, that's right. I remember my answer, huh? Yeah. So is that what it is? 3. So 20 over 6. Yeah, so it's 3.33. 2 places or whatever, so 3.33%. Is that good? But it's nice to have something real in front of us. What does this mean? This is an employment graph. This means from the year 1994 to the year 2000. I don't know, what is this, unemployment or what is this? Whatever. Whatever this, it says the percentage of employment or percentage of unemployment. I don't know. We'll have to look back at the original question. But whatever the percentage is, it went, in 1994 it was at 0%. And in the year 2000 it rose to 20%. Now, it didn't do that directly. It kind of meandered up and down, you know, mostly up, but it meandered a little bit. What's the average rate of change? Well, over 6 years, it changed from a height of 0 to a height of 20. It changed 20 in 6 years. See how the real life thing's going on there? It changed 20 in 6 years. In other words, it changed 3.33 per year on average. That's what you're figuring out. The average rate of change. On average, it went up about 3.33 every year. Over 6 years, that came out to be an increase of 20%. So you'd be presenting this information to somebody in the business community, and you would say, this, whatever thing it is here, this employment percentage, is rising over the last 20 years. It's been rising on average 3.3% per year. That's the average rate of change. How fast it's changing on average. It didn't always rise 3.3 every year, but on average over the last 20 years, that was the average rate of change. That's what slope is. Make sense? Questions on that one? So we didn't have to plug in any functions. We just grab them off the graph. don't work so well anymore. All right, so 92 to 99, is that what it was? I think, right? 92 to 99. See if you can grab some values there. Find the slope, average rate of change. So find two dots. So here's the 1992 dot, right? 92, go up, go over, 5. And the 1999 dot right here, go up, go over, looks like 4. So you know what you're really finding? You're finding the steepness of that line right there that connects those two. Now you're finding the slope of that line, because that line's how it's gone on average, right? Really it's gone up and down and stuff. But that direct straight line connecting those two dots, the steepness of that line is the average rate of change. So that's what we want. Find the slope of that line. Slope is y2 minus y1 over x2 minus x1. Difference of y values over difference of x's. So the two y values. Now this one's y value is, wait, which is the first one? So on the bottom, it's what is it? It's 1999 minus 1992. So the 1999 is actually the smaller one. It's reversed, isn't it? Like that. Yeah, so we get -1 over 7. And they probably want a decimal. Just divide in your calculator, whatever. What is 1 divided by 7? 0.14285. I don't know how many decimal places they want or whatever. Just round it however they want. Negative. It'll be negative. And why is it negative? It's going down. It's decreasing, huh? Whatever. What is this real life thing we're looking at here? I don't remember. But whatever it is, it's going down over time. It's not the cost of living, nor the cost of college, nor the national debt. Those aren't going down. Something else. Questions on that? All right. Flashback. Sounds weird. All right, let's see. Object dropped from the top building, planet X falls. This distance, whatever. Blah, 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 blah. That's their function. Find the average speed, blah, blah, blah. What do they want? They want slope. That's what they always want in this section. You don't even need to really read all the words carefully. Now, you might wonder, yes, that's great, Mr. Harriman. I'm in section 11.3, and I know they're all slope, but what do I do on the final exam next Tuesday when it doesn't say, they're not all coming from section 11.3 and they're slope? What key word, and that's a lot of the battle, isn't it, on a final, is recognition. You know what I mean? So practice that. That's why you got to go over the review, because it's all been a long time. How would you recognize this? Average, that average word. I don't think we've done average any other time. Average speed is slope. Now, I know we haven't called it that, so we've been saying average rate of change. That's what I've been saying, huh? But average, what's a speed? A speed's a rate, isn't it? A speed's a rate. Speed's another word for rate. What was the rate of that car? What was the speed of that car? So average speed, average rate, hopefully then you would remember, slope. This is a slope question. There'll be one of those on the exam, final exam next Tuesday. There'll be one slope question, but it won't say slope. It'll say find the average rate of change, probably what it'll say. Or average speed, same thing. You ever thought about that? That speeds are always slopes, like 38 feet per second or miles. If you drive 60 miles per hour, that means you go 60 miles in your car every 1 hour. It's a slope, huh? Speeds are slopes. They're one thing over the other, aren't they? They're always slopes. Speeds are slopes. Rates, all rates. If I say I can grade 10 papers per hour, papers on the top, hours on the bottom, huh? Speeds are always fractions, aren't they? And they always have time on the bottom. How fast you do anything is always a fraction with a time on the bottom. So rates, speeds, average speeds are slope. So you know the deal, y2 minus y1 over x2 minus x1. Okay, great. But I don't have y, this isn't a graph where I can get y values. What do I do for these y values? I do f values. But I don't really have f, I have that. That's my, it's s instead of f, but it's the same thing. So now what are my two x values here? You know what it is? It's 2 seconds. Can you see it right here? It's a little more tricky. 2 seconds, and they're saying during the first 2 seconds. My variable is t. My plug-in is t for time. So do you realize that means first 2 seconds means time 0 to time 2. So the bottom is 2 minus 0. Does that make sense? First 2 seconds. That's from time 0 to time 2. Those are my two values. And you put the second one first, remember? All right, and then what do you do on the top? You plug those in. S of 2 minus S of 0. That makes sense? So we're using the same kind of thing, right? The two function values on the top, the other values on the bottom. So what is S of 2? Well, got to plug it into that function. 19 times 2 squared. 4 times 4 is 76. And S of 0 is 19 times 0 squared is 0. So it's 76 minus 0 over 2 minus 0. 76 over 2, 38. Yeah, which is the answer. Is that okay with all that? That all making sense? The difference of S values over X values. So Y values over X values. Y values are function values, right? So the function values go on the top. And first 2 seconds mean 0 to 2. Good? Slope, slope, slope. Want to flash off it? Slope, 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 slope. Okay, so they're saying cars moving along a... Why didn't it... I can't even see. It's not even on... Oh, it's on your screen. There. Oh, good. It's okay. It's good for you guys. There's... All right, so anyway, they're giving me... These are basically my X values, and these are my Y values. That's like an XY table. So there we go. It's just going to be the same thing. So let's look at this first question here. It says... average velocity. What's velocity? Speed or rate. Average rate, slow. So you recognize this on the final next Tuesday, right? Average, whatever, speed, rate, velocity, it's all slope. Slope is what? And it says from 1 to 3, so you go 3 minus 1. Those are my X values. X2. Start with the second X value first. X2 minus X1. And on the top, you're supposed to do Y2 minus Y1, right? And what are those? This time we get them off the table. So you notice there's 3 ways. We get them off a graph. We get them off plugging into a function when they give us some kind of f of x equals whatever, you know. And then when they give us a table, we got the x and the y from the table. They're just showing us all the different ways to get the x and the y. So so the 3 x value goes with 7, and the 1 x value goes with 1 y. See how I grabbed that? So we've just had 3 different ways to get x, y values, huh? From a graph, from a table, from plugging into a function. So that'll be 6 over 2, 3. Which is the answer. The rest are the same. Oh, actually, no, I need to help you down with the part D. But everybody good on... So that's the same thing for A, B, and C, but we need to talk about D. Everybody good to there? In fact, why don't we do B, just to be thorough. Let's do B and C. So go ahead and do B. It's saying same thing from 3 to 5 now. So same thing. So 5 minus 3 is the x values, and then put the y values that go with those on the top. So 5 goes with 11, 3 goes with 7, so 4 over 2, 2 on that one, and then finally Let's do part C. Well, that won't be final, then we'll do D. So the difference of the x values, it's from 7 to 5, so 7 minus 5. And what goes with 7 goes with 13. 5 goes with 11, so it's at 2 over 2, 1. All right, now we're ready for part D. Part D says, estimate the instantaneous velocity at 5 seconds using the formula for estimating the instantaneous rate with h is 2. At 5 seconds. At 5 seconds with h is 2. Oh, I didn't know they said this. Yeah, 'cause I didn't really want to talk about that. Yeah, let me just, I'm not going to ask you that kind of question in the final. It's the same answer. I'm just going to leave it at that. I don't feel like talking about h. It's a whole big story, which I don't want to talk about. If you ever take calculus, we can talk about it. It has something to do with some difference quotient in calculus. Anyway, just the same answer. I'm not going to ask you that kind of question in the final. So same answer. Now, was there more than D? I thought there was something. Okay, let's look at this. So here, last thing, this question. Estimate the instantaneous velocity at 5 seconds by averaging the answers. The velocity 2 seconds before and 2 seconds after. That is the answers to B and C. Oh, so they're telling you. The answer to B, it's kind of off the screen now, was 2. The answer to C was 1. They're saying average those. How do you average two numbers? Add them and divide by 2. 3 over 2, 1.5. There we go. So they're basically saying average B and C. All right, let's move on. There's other things I want to talk about. So is everybody okay on that? Did I flash off that too quick? Get that down. So that last part just said average the answers. Right here, see how it says average the answers from B and C? And so I just took the answer from B and the answer from C, added them and divided by 2. Okay. So here we go. Now we're in a totally different ballgame. They want me to do this a little bit more complex thing. They want me, first off, find f of a plus h. Here's the function. So let me write that again. So f of x equals 5 minus 7x squared. So there's the function. You've plugged into functions before, right? That x is just an insert slot. Remember, like holes in a toaster. Insert here, right? That's what the x is. In fact, it would have been, I think, better if math had done it like this. If they just put a blank there and a blank here. Because that's it. Whatever you plug in, just like a toaster, slides right there, right? I just want to make sure you're really clear on that. Whatever I put into a function, it just slides right there. The x is not going to stay around. We're going to replace the x with whatever we plug in, right? That's the part I want to be clear on. Because students that aren't clear on this sometimes have the x and the new stuff. That's a mistake. The new plugged in stuff will replace the x. He'll no longer be there. Like a substitute teacher, right? I don't know if I never had a sub in here, did I? But if I had, did I? Oh yeah, I had Mr. Turnbakis that one day, that's right. Anyway, yeah, so I wasn't here too. I didn't say, hey, we got a sub and I'm here too, right? That'd be dumb, right? When the sub shows up, the original teacher's gone, right? Same thing, when you plug into a function, the x isn't there anymore. The new thing takes its place. Okay, so what are we going to put in? A plus h. So put in a plus h. They're telling me plug in. So where did I put it? Right here. A plus h. Let me rewrite it. It's not very clear. A plus h. Right? This is f of a plus h. Good so far. I'm going to need to FOIL all that out now and do a bunch of algebra, which is easy to mess up, so I'll go slow and be careful. But so far, so good. I just plugged in. The x isn't there anymore, right? Because the a plus h. All the x was, we call it a dummy variable. He's just holding a spot. It's not like he's really there. He's just holding a spot. A plus h plugged in, took a spot. Okay. Now, can I go 2, 5 minus 7, oh, negative 2. Negative 2. That's wrong. Fully wrong. Why? What's wrong with that? Why can't you do that?
Distribute first.
Why do you have to distribute first?
Can't get to the parentheses.
Why? Please excuse me, dear Aunt Sally. PEMDAS, order of operations in math. You're right. Parentheses and multiplying are before adding, subtracting. Remember the order of operations? You can't add or subtract first. Yeah, so you guys are totally right. So don't make that mistake. Can't do that. Okay, that'll be done later, but not right now. So instead, let's do the parentheses first. You're totally right. A plus H, and go ahead and just FOIL that out. Leave the 7 sitting there also. Just FOIL out these parentheses. A squared plus AH plus AH plus H squared. Was that too quick? Do you remember FOILing from algebra? From your algebra days? What did I do there? I can show it up here again a little more slowly. A plus H times A plus H. The A goes to both, first off. And when he's done, it'll be the H's turn and he'll go to both. They take turns, right? The first goes to both, and when he's done, the second does. What happens when they multiply? Well, A times A is A squared. And A times H, there's plus signs between all these, right, is AH. So good so far? The A is done. He's had his turn, so to speak. He went to both, he's done. Now it's the H's turn, and he will go to both. Plus AH. You could write HA, HAH. The order doesn't matter. I'm just going to keep it the same order, AH. It doesn't matter, though. If you have HA, that's fine. Plus H times H, H squared. And then, well, so that's what I've got right there, right? Everybody good how I got that FOIL? Now, keep going. You still can't subtract that 5 and 7. A squared. Remember like terms? Remember these two in the middle are like terms? Remember that from your algebra days? AH, does it make A squared H squared? No. That's when you multiply. Yeah, when adding, you just add the numbers in the front. Exactly. It's 2AH. Remember all that? So if you're multiplying letters, that's when you get the new powers, the higher powers. But we're not multiplying, we're adding AH and AH. So you just add the ones in the front to make 2AH. Does that make sense? You remember those differences from the rules of letters? Right? Again, if you're multiplying x times x is x squared, but x plus x is 2x because you add the ones in the front. Right? So when you're adding, you just add numbers in front. You don't mess with powers, right? When you're multiplying, that's when you do the powers. Okay? Now, I still can't subtract 5 minus 7. Now, the 7 has to have his turn to multiply. So we get 5 minus 7a squared minus 14ah minus 7h squared. And that's the answer I wrote up here. That's the answer to the first part. So that minus 7 just multiplied the 3 terms in the parenthesis. And that means he multiplies to the front, right? So minus 7 went to the front, minus 7a squared. Minus 7 times the positive 2 in the front, minus 14, right? Now minus 7 hits the front, minus 7h squared. That good? That's the answer to the first question. That's f of a plus h. That's f, the function, with a plus h plugged in and worked out. Good so far? Now in the second part, they want me to use that answer I just got from the first part. Let me come up here. So I'll erase some of this. That's okay. So come up here now in the second part and get rid of that. They want me to say, okay, now in the second part, they want f of a plus h minus f of a all over h. Okay, how do I do that? Well, this, remember what this is? I bring it down here. This is f of a plus h. So that goes right there, huh? That whole big long thing. 5 minus 7a squared minus 14ah minus 7h squared. And then this is f of a. So minus f of a. Now what's f of a? Well, see, it's the function with a plugged in. Where's the function? Right here. Here's the beginning. First time they gave me the function, right? Where's the insert slot? Right there. What are you going to plug into the toaster there? What are you going to plug into the slot? It's saying put in the A. So just take that and go 5 minus 7a squared instead of x squared. Everybody see what happened there? I plugged a in the place of x, right? The substitute teacher took the place of the regular teacher. The a subbed into the x slot. Because it wasn't f of x, it was f of a. They were saying put a into the f machine. Plug a into the function. So you put a in the x slot, right? That's where things go. When you plug into a function, they go in the x slot, right? All over h. So I just did all of this. Everybody see it? This part is the f of a. This part is the f of a plus h. And then there's the h on the bottom. Everybody see all that? Now I got to clean that up. This is algebra intensive. This is actually something you do in calculus called the difference quotient. You're doing calculus right now. Really. It's the beginning of calculus. So I got to clean this up. So first thing, now I put parentheses here. Why did I put parentheses here? Because you're subtracting f of a, all of f of a. So you have to put parentheses to do that correctly, because you're subtracting the whole. It said right here, subtract f of a. If I just wrote minus 5 minus 7a squared like that, that wouldn't be subtracting all of f of a. That would only be subtracting the front part. That minus sign never made it to the back if I do that. So that wouldn't be true to the original meaning of subtracting all of f of a, you see. So you need the parentheses. Okay, so what do we have here? 5 minus, let me just change my color here. And so I'm just going to, what I'm going to do, I'm going to recopy the first part. Then this minus sign, remember a minus sign in front of a fraction? It distributes. In fact, I should put it right there, huh? Everybody good with that? So it's going to be minus 5 plus 7a squared. Everybody see what happened on the sign there? See how that 7a squared became positive? Why did that happen? Because this minus sign hit the front of the 5 and the front of the minus 7, and minus times minus made plus 7a squared. Everybody see that? So first thing is always those parentheses. So I got rid of the parentheses. When there's a minus sign in front, it distributes. Now, gather like terms, or better yet, cancel things, right? 5 minus 5, gone. Everybody see what's happening? Am I racing ahead of you? I'm canceling 5 minus 5. Minus 7a squared plus 7a squared. We good? Minus 14ah minus 7h squared all over h. We're almost there. One more step. Been a lot of algebra. Yeah, now can I just cancel those h's? No. You have to cancel this one of these ones also. If you do them both, it's okay. You have to do one from each group together. So you get minus 14a minus 7. See why there's one? There was 2 here. H squared was 2 h's. One of them canceled with the 1 on the bottom, leaving just 1. And the other one right here is gone completely because there was only 1 there. There's our answer finally, which is what I wrote down as the answer. Oh, actually, they're asking another question too, huh? That'll be easy, but this was the hard one. So are we good to there for the second part? This is the mammoth question here.
It's probably off topic, but if one of the terms didn't have an H, would you still be able to?
Yeah, no, that's a good question, Jesus. You're right on topic. Yeah, they have to both have the H.
Okay.
They have to both have it. They will on these. They won't give you that kind of stuff. That doesn't. Yeah. So yeah, so you cancel 1 H from each group. and they would have to be there. If they weren't, the official algebra rule is if they weren't, you couldn't cancel anything. It would just stop where it was at. So good to there? So that'll take a little bit of practice. There's a lot of algebra rules. Now, last question is, if that's not enough, last question is, where is it? Oh, there it is. Instantaneous rate of change. What's that? And where in the world did that come from? Well, I'm going to give you a rule to do that. In fact, let me just go to a fresh screen. Everybody got that copy down? All right. Let's answer. So instantaneous rate of change. Okay, so how do you do instantaneous rate of change? The rule is, well, first off, do you realize this is a different question than they've been asking me? They've been asking me what? Average. Average. Think with me for just a, before I go into the details of how to do this, I want you to understand that it's a different kind of question. What if I said, hey, I went to LA last weekend? I did not. But I traveled, let's say, I traveled, how many, 200 miles? And I did it in 4 hours. So I traveled 200 miles in 4 hours. What was my average rate, speed? Yeah, you just take the 200, divide by 4, 50 miles an hour. Now, that's my average speed, huh? That doesn't mean I always went 50 miles an hour, does it? Right? I didn't come out of my driveway at 50 miles an hour. My neighbors wouldn't appreciate that. Right? So kids might enjoy it, but neighbors wouldn't. So, right? So I came out slow and then got on the freeway, probably did 60, 65, most of the way, maybe stopped for, maybe I went 80 and stopped for lunch for half an hour in there. Right? But who knows? The average was 50, right? That's different than if I said, hey, what was my speed at the instant 1 hour into the trip? 1 hour into the trip, right then, right? What did the speedometer say right at that instant? You know, like black boxes record inside cars and planes and things, right? They keep track of your speed at every instant, right? That's a different kind of question, isn't it? Totally different, to have an instantaneous speed. That's what calculus is able to do. That's what a lot of what calculus is about. Maybe the first Calc 1 is a lot about that, is about getting instantaneous speeds on things. All right, so first off, it's a different question. Just wanted to give you that idea. So when you read this, there probably is one of these on the final. There's an instantaneous question. How do you do it? Well, bunch of special fancy calculus rules, but I'm going to keep it simple and just give you one simple rule, which is all you need. It's all that's going to be required for this class. It's one simple calculus rule. Basically, when you have, let's say, ax to the n, to find the instantaneous, I can't spell that word very good, taneous, can't believe how many A's and N's it has. Instantaneous rate. What you do is you bring, that's an A in the front there. You bring the n down to multiply and you lower the power by 1. And constants, meaning numbers with no letters, constants vanish. I'll just say they vanish. They become 0 or they vanish. All right. I don't know how you are reading math formulas and feeling all good about it. Maybe you don't. Let me show you. So for example, let's practice. Examples will help, I think. If I had like 7x to the 4th, and somebody says, do the instantaneous thing on it. This is the calculus rule for doing the instantaneous rate of change. You take that 4 and you bring it down to the front. So it becomes 7 times 4, 28. You can make it 28 right now if you want. I'll do it in a minute. I'm just showing the step. 7 times 4, right? So you see how that n came down. Whatever the power is, it comes down and multiplies the number in the front. That's what I'm showing here, right? The a that was already in the front times the power that used to be up here. And then what do you do with the power? It changes. Subtract 1 from it. So 4, subtract 1, will now be 3. So it's 28 x to the 3rd done. Does that make sense? You take that power, multiply the front, lower the power by 1. That's what that rule is saying. Just take the power, multiply the front, lower the power by 1. So what if I gave you 10x to the third? What would be the instantaneous? Yeah. Everybody good with that? So you just grab that 3, bring it down to the front, 30, lower the power by 1, boom. 30x to the second. Is that okay? You're taking derivatives, it's called. You can tell people you did some calculus. This is calculus. This is derivatives. This is the beginning of calculus. So just the number in the front. Power multiplies the number in the front, lower the power by 1. So, okay. What if they give you like just a 10? No x at all. What did I say here? Just 0 or vanishes. If you don't have an x and you do the instantaneous thing, gone, just vanishes. Making sense? So, having said all that, let's do that for our function. That's what they're saying. Do the instantaneous for our function. So I had 5 minus 7x squared. I'm going to do the instantaneous thing now. There's 2 parts. What happens to the 5? Vanish. Right? Numbers that have no letter, called constants, they don't have a variable, they don't vary, they're constant. They vanish, poof, when you do the derivative, right? The instantaneous rate of change. And then what's gonna happen to this? To keep that negative in front, that's his baby, right? That negative in front of 7, that's on the 7. So can you do that one? So the 5 just vanishes because it didn't have an x. It's just gone. And so we do with that 2. Multiply, minus 14, lower it by 1, x to the 1, or just x if you want. Same thing. Is that good? The 5 vanished. The 2 came down to the front and multiplied, and then subtract 1 from the power, it's down to 1. Minus 14x to the first, or just x. Same thing. Last step, they said when a is 2, that's your plug-in. Remember, a is what we're always plugging in. So do that first. Do the, multiply the number in the front, lower the power by 1, and then plug in whatever they tell you to plug in. They're saying plug in 2. So minus 14 times 2. Which is minus 28, which is the answer we got. Does that make sense? We just did a derivative, it's called. We found the instantaneous rate of change. How fast the speed was at that instant, not just an average over 2 time periods. Is that okay? See how those derivatives work? So there's one instantaneous on the final next week. So power to the front, lower the power by 1, constants vanish, and then plug in your number. It's an instantaneous rather than an average rate of change. Lot more helpful information, specific information. It's very useful, real life. That kind of calculus does all kinds of things that we need. All right, so is that good if I flash off of that? How we get to review today? I'll be lucky just to finish this up. All right, so average. I'm going to skip the average. Average is the same, right? They're going from 1,002 to 1,007. So you just go 1,007 minus 1,002, and then this would be R of 1,007 minus R of 1,002. You got to plug. Here's the R function. You got to plug in dot dot dot. Right? That's the same thing it always is, right? Difference of function values, because that one's just saying average again. Same thing we did before. Good. Now, I want to get to this one. Marginal. What's marginal? Marginal is another word for instantaneous. Why? How do you know? Marginal. How big's, if I say, it's only the margin. Well, I even said it, huh? What's the margin of your paper? It's the small little edge, right? Margin means small. If I say, the gain was marginal, what do people mean when they say that? Small, it's tiny, hardly noticeable, right? So when they say marginal something in business, they mean small, quick. So marginal revenue means at an instant. Like, what was the revenue? What is the instantaneous revenue? That's what they're asking. They're saying, look, we want to know if this is a revenue function, what is the instantaneous revenue? The marginal revenue. Oh, I kept wondering where the numbers, at 100. Yeah, they're saying marginal revenue at 100. So that means we got to do the instantaneous thing. We got to take this function, what is it? R of x equals 10x minus 0.01 x squared. Can you do the marginal or instantaneous, same thing, on that function? What's the power on that 10x to the 1? What's the power right now? 1, yeah, so 1's up there. So go ahead and do the rule. What do? You grab the power, multiplies the front, lower the power by 1. What's x to the 0? Anything to the 0 power is 1, so it just turns into a 1. The x, right? Let me help you with that first one. The 1 comes down, 10 times 1 is just 10, lower the power by 1. That's just going to be 10, because x to the 0 is 1, so that's just 10. So the whole thing doesn't vanish. It's not one of those, it's not just a number without an x, which would vanish, but it is a number with where the x just turns, the x itself goes away, because it's x to the 0 power. What about the other one? The 2 comes down, 0.02, lower the power by 1, x to the 1. Good to there so far. And now, plug in. They told me to plug in right here. X 100. So plug in x 100. And you get 10 minus, what is that, 2 equals 8. Now, why am I getting the answer 8? Yeah, that's the other thing that's tricky on this one. Notice what they're saying. The revenue in thousands of dollars. I'm not going to do that to you on the test. They're just playing games here. I don't like when they fiddle around with the numbers like that. So it's in thousands. So on this question, when they say how many dollars, that 8 means 8,000. So anyway, I'm not going to do that on the final. So the actual answer is 8,000 because that 8 is in thousands. They said so here. Is that okay? I think we're about out of time. So let me glance. Everybody got that copy down? I just want to make sure I'm not leaving you high.